In the previous lecture, we discussed the transmission of the light through different objects and different materials. Whenever they go through the different materials with the different densities, the light is going to refract or bend whenever it passes through this material or when it's going out from this material. So for example, whenever the light is passing through this lens in the form of the prism, it's going to refract and bend in this way. So depending on the shape of the lens, the light is going to bend and transmit through this lens in a different way. So we are going to differentiate the two types of the lens. One is going to be the convex and another one is going to be concave one. So whenever your the lens is going to be a convex form, it's going to be in this form, where the middle of the lens is going to be more thicker. So the middle of the lens is going to be more thicker. So sometimes we call this kind of lens as a converging lens as well, because the light which is passing through this lens is going to converge at some point. For example, let's consider an example. So the light is passing through from here, it's going to go like this. Whenever the light is going through the center of the lens, it's passing through. It's going like straightforwardly. So whenever the light is coming from this point, it's going to go like this. So you see, so the lights which are passing through this lens are going to converge at some point. So that's why we call this kind of lens as a converging lens as well. Converging lens. So we call another type of lens as a concave when the middle of the lens is going to be more thinner. So the middle is more thinner. And sometimes we call this kind of lens as well as a diverging lens, because the light which is passing through this lens are going to diverge. So in the center, it passes through the straightforwardly, and in the top and in the bottom, it's going to diverge after it passes through this lens. So this kind of lens also called as a diverging lens. So it has the many applications, and especially in medicine, we can apply the convex or concave or converging or diverging lenses in order to treat with the far-sighted and near-sighted people. So this is the structure of the eye, and this is the lens of the eye. So the light which is passing through the lens is going to converge at some point. So we see the object in a perfect way, in a good way, if this converging point is at the end of the eye structure, which is called as the retina of the eye. And then so our mind is going to understand this some way, and we can see the objects in a good way. So whenever this convergent point is before the retina, so we call this kind of eyes as a near-sighted eyes. So so technically it means that the light is converging before the retina. In order to treat with this, we are going to put some lens before the eye, so that the light is going to converge exactly on the retina. So can you guess what kind of lens we need to put here in order that the light is going to converge exactly to here? Yes, exactly. It's going to be the diverging lens. So if we put the diverging lens to here, so the light is diverging to here, then again it's going to converge after it passes through the lens of the eye, and it's going to converge exactly at the end of the eye structure, at the retina. And another problem is for the far-sighted eyes, so where the light which is passing through the lens is going to converge after the retina. And again, we are going to deal with the people with the eye which is not going to see the objects in a good way. So we need to put again a lens to here before the eye, so that whenever it passes through the lens and the lens of the eye, it's going to converge exactly on the retina. In this case, we are going to use the converging lens. So here, so if we put the converging lens, so the light is passing through this lens, and then the lens of the eye is going to converge exactly at the end of the eye structure at the retina. So this is how we can deal with the treatment of the of the farsighted and the nearsighted eyes. So today in the lecture we're going to discuss how the eyes, so how the images are formed whenever it passes through the lenses. So here we've got an object, and it's going to send a light, for example, to the lens of the eye. So whenever it passes through the lens, it's going to form some image, and we're going to discuss how those images from the objects are formed. So the formation of those images from the objects is done using so-called ray diagram. So basically it contains the 3 steps of forming them. So the first step is, so first of all, let me explain here the structure of this image. So here, so this is an object, and the light, for example, the light of the sun, which is reflecting from this object, is going to pass through our eye, and it's going to form some image. And we would like to figure out where this image is going to be formed, and what is going to be the size of this image, and what is going to be the position of this image, and so on. So this line is called the optical line, and this is the converging lens, and this point is called the focal line. So basically what does it mean is that if we draw a center of this convex converging lens, the distance between this point and the center of this lens is going to be called as a focal distance. Focal distance. So this focal distance actually is equal to the radius of this curvature. So basically if this is the radius over 2. So this distance, focal distance, is equal to the radius divided by 2. So you can see this in this image is roughly equal to the radius over 2. So, and this point is going to be called as 2 focal points, which is going to be equal to the radius of this curvature. So in order to make an image from the object, we need to do this in the 3 steps. The first step is going to, so we are going to draw a parallel line to the optical line. Then whenever it passes through the converging lens, it's going to go through the focal point. So first parallel, then through the focal. So let's draw this. So let me erase this one in a moment. So it's going to be parallel first of all, then through the focal point. The step number 2 is, so we are going to draw a line which is passing through the focal first of all, then parallel to the optical line. So first of all, it's going to go through the focal, then parallel. And in the step number 3, we are going to draw a line which is going to go through the center of the lens. It's going to go through exactly the center of the lens. And intersection of the 3 lines is going to tell us where the image is going to be. So this is going to be our image. So you can see that the size of the image is going to be smaller than the actual size of the object, and it's going to be reflecting. It's going to be inverted, right, through this line. And our mind has a special feature in order to understand it. So it automatically reflects this, and it understands that this is the object and this side, more or less. So this is how we are going to form the image. So this is going to be the image of the object, and we can do this through the 3 lines which is passing through the lens. So we draw this image whenever our object is here. It's after the focal point. But if this object is before the focal point, we are going to have the different image. So let's consider the situation. So let's say I've got an object which is located before the focal point. So the focal point is here and here. And again, in order to form an image from the object, we need to try to do the 3 steps. Step number 1 is we need to draw a line which is parallel, first of all, to the optical line, then which is going to go through the focal point. So it's going to be parallel, then through the focal point. So in the step number 2, we need to draw a line through the focal point, then parallel to the optical line. So in this case, we're going to use this focal point in order to draw this. So our light is going to go through the parallel, through the focal point, and then parallel to the optical line. And do you see that after passing through the lens, these two lights are going to be, so these two lines are going to be diverging, so they're not going to converge after they pass through this lens. It means that we can find a convergence, so the point where they are going to converge at some point is going to be before this lens. So basically, in order to do this, I'm going to continue this red line, and also I'm going to continue this blue line. And at the end, we need to draw a line, and step number 3, we need to draw a line through the center of the lens. So this light, it's going to be like this roughly. And the intersection of the 3 lines is going to tell us where we are going to have an image. So this is going to be the figure of our image. So do you see? So in this case, the image is going to be on the same side as an object. So this kind of image is called the virtual image. Virtual image. So this is going to be our virtual image, and this is going to be our, so this kind of image, which is on the another side of the object, is going to be called as a real image. So this is the image, and this is the real one. So this is going to be a virtual. So the definition of the virtual image is that the image which is formed by this lens from the object is going to be on the same side as an object. So for example, the example of the virtual image is your image whenever you look to the mirror. So it's a virtual image. And this is going to be a real image, which is on another side from the object. We are going to do a couple of simulations using the online simulation tools. So before we do this, let's discuss how the image is forming whenever we have the diverging lens. So let's say I've got an object and I've got the diverging lens to here, and I'm going to try to apply the 3 steps, so it's 3 ray diagrams in order to form the image. So do you remember the first step is we need to draw a line which is going to be parallel first of all to the optical line, then which is going through the focal point, right? So let's draw this. So it's going to be parallel. So intuitively, what we did before, so the light was going through the focal point here. So, but we know that this is the diverging lens. So after the light is passing through this point, it's going to diverge. It should go up, right? And the light which is passing through the focal point is going to be, so with the focal point which we're going to use is going to be this one. So this focal point we are going to use now. So the second step was, so in the second step, we need to draw a line which passes through the focal point first of all, then parallel to the optical line. So we're going to draw this in this way. Sorry. Focal point. And again, whenever it passes through this here, so it's going to diverge and it's going to be roughly like this. So let me draw this in this way. So it passes through the focal point. And it passes through like this. So whenever it touches this, it passes through like this. And the last one is going to be through the center. The last one, it's the line through the center of the lens. It's going to go like this exactly. So now we need to find the intersection of the 3 lines, right? Do you see? So the intersection of the blue and red here. So actually, if I continue this light to here, I've got the intersection here, right? And actually, this is going to be the same point as if I continue the green light from here. So the intersection of the 3 lights, again, is going to be our image. So our image is going to be here. So this is going to be our image. And since this image is on the same side as the object, it's going to be, again, the virtual image. So the diverging lens is always going to form a virtual image. And in order to form this image, again, we need to draw the 3 lights. And this is called the ray diagram. So in the next video, we're going to discuss the simulations a bit, how to play with these ray diagrams for the different lenses and for the different positions from the focal points.